Hello, software testing folks.
Agenda for today's video is categories of test design techniques, specification-based or black box techniques, structure-based or white box techniques, experience-based techniques, choosing a test technique. Categories of test design techniques. There are many different types of software testing technique, each with its own strengths and weaknesses. Each individual technique is good at finding particular types of defect and relatively poor at finding other types. For example, a technique that explores the upper and lower limits of a single input range is more likely to find boundary value defects than defects associated with combinations of inputs. Broadly speaking, there are two main categories, static and dynamic. Static testing techniques do not execute the code being examined, and are generally used before any tests are executed on the software. They could be called non-execution techniques. Dynamic techniques are subdivided into three more categories: specification-based, also known as behavioral techniques, structure-based, also known as white box or structural techniques, and experience-based techniques. What are the differences between white box and black box testing technique? Black box technique derives test case based on requirements of the module, mostly used by independent test users. They are suitable for system test and acceptance test. White box technique derives test case based on internal structure of the code, mostly used by software developers. They are suitable for unit test and subsystem test. White box test technique used predominantly at lower levels to complement black box. Black box test technique appropriate at all levels but dominates higher levels of testing. We now will discuss in detail of following specification-based or black box techniques. Equivalent partitioning. The idea behind this technique is to divide a set of test conditions into groups or sets that can be considered the same, hence equivalence partitioning. Equivalence partitions are also known as equivalence classes. In the example below, for the input with a range of 1 to 100, equivalence class divides the input into three sets. Input 1 with the value is 0, input 2 is any value between 1 to 100, and input 3 is 101. Boundary value analysis is based on testing at the boundaries between partitions. If an input condition specifies a range of values, write test cases for the ends of the range, and invalid input test cases for situations just beyond the ends. For instance, if the valid domain of an input value is -1.0 to 1.0, write test cases for the situations -1.0, 1.0, -1.001, and 1.001. If an input condition specifies a number of values, write test cases for the minimum and maximum number of values and one beneath and beyond these values. For instance, if an input file can contain 1 to 255 records, write test cases for 0, 1, 255, and 256 records. The important difference between boundary value analysis and equivalence partitioning is that boundary value analysis explores situations on and around the edges of the equivalence partitions. One weakness of boundary value analysis and equivalence partitioning is that they do not explore combinations of input circumstances. Cause-effect graphing or decision table technique aids in selecting, in a systematic way, a high-yield set of test cases. Please refer the book, Art of Software Testing, presented in this website. www.softwaretestingonline.com to know more details with example. A decision table is a good way to deal with combinations of things in a systematic selection of effective test cases, and can have the beneficial side effect of finding problems and ambiguities in the specification. In the below table, based on the input conditions, output is expressed either as true or false. A finite state machine simply means that the system can be in a finite number of different states, and the transitions from one state to another are determined by the rules of the machine. For example, If you request to withdraw $100 from a bank ATM, you may be given cash. Later you may make exactly the same request, but be refused the money. This later refusal is because the state of your bank account has changed from having sufficient funds to insufficient funds. The transaction that caused your account to change its state was due to earlier withdrawal. A state transition model has 4 basic parts. 1. The states that the software may occupy here, that is either funded or insufficient funds. 2. The transitions from one state to another, example shows not all transitions are allowed. 3. The events that cause a transition, example, closing a file or withdrawing money. 4. The actions that result from a transition, which can be an error message or being given your cash. Use case testing is a technique that helps us to identify test cases that exercise the whole system on a transaction-by-transaction basis, from start to finish. A use case is a description of a particular use of the system by an actor. Each use case describes the interactions the actor has with the system in order to achieve a specific task. Use cases can uncover integration defects, that is, defects caused by the incorrect interaction between different components. We now see the different white box techniques. Structure-based techniques serve 2 purposes. One is test coverage measurement, and structural test case design. They are often used first to assess the amount of testing performed by tests derived from specification-based techniques, that is, to assess coverage. They are then used to design additional tests with the aim of increasing the test coverage. Structure-based test design techniques are a good way of generating additional test cases that are different from existing tests. They can help ensure more breadth of testing, in the sense that test cases that achieve 100% coverage in any measure will be exercising all parts of the software. Statement coverage is percentage of executable statements exercised by test suite. Studies and experience in the industry have indicated that what is considered reasonably thorough black box testing may actually achieve only 60% to 75% statement coverage. Fail-safe section of the code are less likely covered as part of testing. Typical ad hoc testing is likely to be around 15%, this leaves 20% of the statements untested. A stronger logic coverage criterion is known as decision coverage or branch coverage. This criterion states that you must write enough test cases that each decision has a true and a false outcome at least once. In other words, each branch direction must be traversed at least once. Examples of branch or decision statements are switch case, do while, and if-else statements. Decision coverage usually can satisfy statement coverage. Coverage is the ratio between number of decision outcomes exercised, and total number of decision outcomes. Experience-based techniques. There are 2 types. Error guessing is a technique that should always be used as a complement to other more formal techniques. The success of error guessing is very much dependent on the skill of the tester, as good testers know where the defects are most likely to lurk. Exploratory testing is a hands-on approach in which testers are involved in minimum planning and maximum test execution. Design and test execution activities are performed in parallel, typically without formally documenting the test conditions, test cases or test scripts. Technique is most useful when there are no or poor specifications and when time is severely limited. Choosing a test technique. There is no single testing technique as best test technique. Internal factors that influence the decision are: models used, tester knowledge and experience, likely defects, test objective, documentation, life cycle model. External factors that influence the decision are: risk, customer contractual requirements, type of system, regulatory requirements, time and budget.
Thanks for watching.